from that angle of the triangle. Okay. All right, so now let's go and talk about multiplication of binomials. Now, the student wanted me to go ahead and just multiply binomials, and I could quickly, easily do that. That's not a problem at all. But for some reason, I just kind of thought if they're asking me to multiply binomials, they probably are having a little bit trouble of like, I don't know, maybe an easy way to like remember or to understand what the multiplication of binomials is doing. So, if I was going to multiply 3 by 4, I'm just going to do a little bit of elementary here. If I was going to multiply 3 by 4, a lot of times we just do, 3 times 4, and we know the answer is 9, right? Or no, we don't know the answer is 9. We know the answer is 12. 3 times 4 is going to be 12. All right. Now, some of us just have those multiplications tables memorized. Obviously, I did not. And then sometimes we also have looked at it as far as finding the area, right? Because if I had like a length times width, we know that would give us the area. But sometimes understanding like how does area fit in with the multiplication of two numbers? So if I had 3 here, we could call this as 3 rows. And if I have 4 here, we could represent this as 4 columns. Okay, so I have 3 times 4. You could have 3 rows of 4 columns. And what you can see here, I'm not really sure if that even made sense, 3 rows of 4 columns. But you have 3 rows, 4 columns, and what they make is they make up 12 squares. You can even count them. You can see how there's 12 squares. So that's how we can represent here 12 representing the area of some rectangle in units. Now, you could do that exact same thing you could do that exact same thing with the x's, but sometimes it gets a little confusing in that point. So what I'd like to do here is just kind of remind students of like the distributive property. Like when you have a value that's outside of the parentheses, you can just distribute that. So x times x is x squared. X times 1 is just going to be x. Okay. So I'm going to approach this in 2 different ways. So we can do this kind of like geometric visualization way, or we could also just kind of memorize what it means when we have something multiplied outside parentheses. So the first way is just knowing, I'm just going to kind of go back to this parentheses way. Well, I know that this is going to be, if I need to apply distributive property, you need to apply it for both. So therefore, that's what we're going to do. We're just going to multiply 2x times both of these terms. Okay. And then we can multiply the -1 times both of the terms. Okay. And sometimes we can solve this like the FOIL face, or I think I even did the FOIL face upside down. Either way, whatever like kind of trick that you can remember to apply to distributive property. But basically, when you have something outside the parentheses, you need to multiply it times every single term inside the parentheses. And obviously those terms need to be separated by addition or subtraction, right? We're not multiplying the 3 and the x, we're just multiplying that by 3x. So you could go ahead and list them out together. But for the sake of time, I'm just going to multiply. So 2x times 4 is going to be 8x. 2x times 3x is going to be a 6x squared. -1 times, let's do top. -1 times 3x is a -3x. And -1 times 4 is a -4. Okay, now we're going to write this in standard form where we're going to have our first degree listed first and then go down in descending order. So we could have a 6x squared. 8x minus 3x is going to be a positive 5x minus 4. And I didn't really do that as well as I would like to. But again, it doesn't really matter if they're not in order. You can just re-put them in order at the end. Now, let's go ahead and just take a look at this way, because some people always get confused or they'll make a mistake. So remember, you can always like fall back on this idea of area, because we know that 3 times 4 represents the area of a rectangle. Now, again, this is confusing though for a lot of students because x is an unknown, right? So what I'm going to do though, if I have 2 terms of this binomial, I'm just going to represent them as 2x and -1. And then over here, I'll represent this as 3x plus 4. Okay. And again, we don't know the value of x, and we're not trying to pretend we know the value of x. We're just using that as a variable, but we know that the product of these two is going to represent the area of this rectangle. Well, now, just like these represent unit boxes, like 1 times 1, here we're just going to find the area of each of these, and then we can add up each of these. Like basically, let me put it this way. This is like 1, 1, 1. this is like 1, 1, 1, 1, right? 3 ones get us 3, 4 ones give us 4. So 1 times 1 is 1. And that's why we added all of those up when we found the area of each of those to give us 12. So here, that's exactly what I'm going to do. 2x times 3x is 6x squared. 2x times 4 is going to be a positive 8x. 3x times negative 1 is a negative 3x. And negative 1 times 4 is a negative 4. So now you can see that, again, that is our area. And you can see that on the diagonal, those add up to give us a 5x minus 4. Okay, so for simplicity and speed, I would just use the FOIL or distributive property. However, when you sometimes get something that's a little bit more complicated, or if it gets a little messy trying to do that,